Hello everybody, this video is an introduction to binary. So you may have heard binary before, and you may have heard that it's how computers can communicate. You may have heard that it's ones and zeros and nothing else, and both of those statements are true. So I'm going to draw an example here. This is an example of a binary number, and this binary number here actually represents the number 5. So this is another example of a binary number, and binary numbers are used to represent real numbers, such as in this example 101 represents 5. This number here represents a number much greater than 5, and with binary we can also represent things like, emojis, we can represent letters, we can represent multiple different things, and these ones and zeros get transported from one machine to another. So it might get transported from your laptop to your friend's laptop, and you don't see all these ones and zeros being passed. What you might see is a message, and the message might say, hello, whoever. So I want you to keep in mind that this video is an introduction. I'm not expecting you to be able to know binary or be able to learn binary all within this video. This is just a really high level overview just to get you familiar with some of the names, some of the concepts, and in future videos we'll be going into detail on every single part that we cover in this video. So the next thing I want to talk about is a bit and a byte. So a bit is part of a byte, and a bit is actually just one of these ones or zeros. So a bit can be 0 or it can be 1, right? That's the only two options a bit can be, and it's only one of these. So then when we move on to bytes, bytes is a little bit different. So bytes is the same as a bit in the fact that it can only take in ones and zeros, or it can only contain ones and zeros. But instead of just having one value like a bit can have multiple values. So it could have like 1 0 0 1 1 1 0 1. So as you can see, if we count these up, we have 1 2 3 4 5 6 7 8. So we have 8 of these ones and zeros, and this is called a byte. So we could think of it as a byte is the same thing as saying 8 bits. So a byte, so 1 byte is the same as 1 bit multiplied by 8, or 8 different bits. And we use the words both bit and byte, but more so byte, because if we want to represent a number like this number 5 here, we would represent it using 8 bits. So it's the same if we want to go and represent like a letter A or B or C, we'd represent it in a byte, because we can't use a bit because a bit would be too small. So you can see, for example, the number 5 here contains 3 bits. So we'd never be able to represent 5 using just 1 bit. So we can use bytes because we have more flexibility. We have 8 possible different combinations. We have 8 different slots to use either 1 or 0 in. So you might have heard of binary being called base 2. And the reason why it's called base 2 is because there's 2 different outcomes, right? As we discussed before, it can be either 0 or 1. That's what binary is. It's 1 or 0. Then we also have base 10, which you're probably more familiar with. So base 10 is what we'd use in the likes of normal maths. So in base 10 we can use numbers like 0 and 1, so it's the same as binary, but in base 10 we can also use 2 and 3 and 4 and 5 all the way up to number 9. So 0 to 9 gives us 10 different possibilities, while base 2 gives us 2 different possibilities. Base 10 is a much better way of representing numbers because you can represent different numbers and different quantities using a smaller amount of space. The problem is with computers, they can only understand ones and zeros, and the reason behind this is because it's an electrical device. Okay, so it's plugged into your electricity supply, and the computer is supplied with current. So when we think about current coming in to supply our machine with power, so when we plug in our computer, or if we have a battery in our laptop, we're supplying power to our machine. So then we can create a voltage, and the voltage can be one of two possibilities. The voltage can be low or the voltage can be high. If the voltage is low, we represent this in the computer as a 0, and if it's high, we represent it as a 1. That's the issue. It's fundamentally the way that computers work. You could argue that could we not have like a medium, and then you would have like a voltage which would be in between 0 and 1. They've tried this in the early days of computing, but there was problems. What would happen is sometimes if you have let's say a medium value in here, the medium value could sometimes be, misread by the computer, and the computer may think that the medium value is actually a low value because it's quite close to 0, or it might think it's a high value because it's quite close to the higher value threshold. So that's why they decided in the end to go with just 0 and 1, so high and low. So the final thing that I want to discuss in this introduction is gates or switches. So if we have a computer and you can imagine that it has a certain state, let's say, we're storing a value like before. Let's say it's 101, which we seen in the beginning of this video represents the number 5, okay? But then maybe we want to change this number. We want to change this number to maybe add 1, so we want to add 6, or maybe we want to take 1 away from it, so we want this number to represent 4. Now to do this, we have to use like switches and gates. And what happens with these gates, sometimes referred to as logic gates, these logic gates will take in binary, they'll take in our ones and zeros, and they'll perform some sort of manipulation on them. So for example, we have 3 main types of gates. We have an AND gate, we have a NOT gate, and we have an OR gate. And what these 3 types of gates do is they take in values and then they provide us with an output. So for example, with the AND gate will take in 2 values. It could be 0 or it could be 1. And if these numbers are both correct, we will get an output which will be either 0 or 1. In this case, these two would have to be the same, so they're not the same, so we get 0. A NOT gate takes in 1 value, so it could be 1 or it could be 0. So if it takes in 1 or 0, the output will be whatever the opposite of that is, so it could be 1 or 0. Then with OR, we can take in again, we take in 2 values, which is 1 and 0 in this case, let's say. So if either of these values are true or 1, our output will be 1. So we'll see this. I'll go into this in more detail. I'll be going through examples of the different types of gates again. I'll be going through a detailed description of how they work along with multiple examples. But this is just a quick introduction to binary and how computers work.